exponential and logarithmic forms. So recall, we have the definition of a log function. It is as follows. So y equals log base a of x if and only if a to the y equals x. So what do I mean by that? We know that 2 to the 3 is 2 times 2 is 4 times 2 is 8. We call this exponential form. If we wanted to write this in logarithmic form, we would write log base. So a is the number that's in the base here, so 2, of x, that's the number that's the output, so 8 equals 3. So this is called the logarithmic form. We're going to look at a couple of examples where you go between logarithmic form and exponential form. Okay, so we're going to write each equation in exponential form. So we know that by definition, log base a of x equals y is equivalent to a to the y equals x. So if we're given an expression that's in logarithmic form, we can convert it to exponential form using this right here. So the way that I think of it is I do this thing to the y. So you do a to the y. In other words, I can write 3 to the z. I take the base here and put it to the z. And then it's equal to whatever was inside of here. So in this case, it's equal to whatever's inside the log. So equals w. So I go kind of like in a circle. 3 to the z equals w. Now if we do that for the second one, it looks a little different because we don't actually see a base for the log. Now when you don't see a base for the log, it means that it's log base 10. So we don't write the 10 when it's log base 10. So for this one, we can do our circle again. And so what we would do is we would say 10 to the c is equal to a. So I go in a circle and I write 10 to the c equals a. And so both of these are considered to be exponential form or the exponential form of the logarithm. Okay, so let's go the other direction. Write the equation in logarithmic form. So just to remind you, we have log base a of x equals y if and only if a to the y is equal to x. So if we want to go backwards and take this exponential form and write it as a log, we need to write log base something of something equals something. So how do we know what goes in which spot? Well, the base here, this is our a, so I'm going to put it in the a spot. In other words, I'm going to put 5 right there. The exponent is our y, and I'm going to put that in the y spot, which goes right here. So that's w. And then whatever is on the outside right here, that's our x value. And so p is going to go in our x spot. So I'm going to put p right here. So our logarithmic form of this expression is log base 5 of p equals w. You can double check your answer by doing this thing, this kind of like circle thing I like to call it, where you see, okay, we need 5 to the w equals p. So 5 to the w should be equal to p. Now let's double check. 5 to the w equals p, so that works. Okay, let's do part B. So we want to rewrite 10 to the f equals g in logarithmic form. So I'm going to put log base something. So log base something of something equals something. So we need to fill in 3 spots. So whatever is in the base of your exponent, that's what goes down as the base in the log. Whatever is in the exponent of the exponential expression, that's what goes in the spot on the right. So that's where our f goes. And then whatever is outside here, so the exponent equals a number, that's what goes inside the log. So that's where our g is going to go. And then we can double check by doing our circle, and so we check 10 to the f equals g. So 10 to the f equals g, and that's exactly what you see here. Now, when you have log base 10, you don't write the 10. That's convention. So if I want to write this correctly, I would just leave the 10 off. That is only done when you have log base 10.